All right, happy Tuesday. Sorry I couldn't be in today, but this is what we need to figure out. We started on Friday talking about the beginnings of apportionment. And the whole idea behind apportionment is to take a population and divide up seats, representatives proportionally so that everybody has a fair amount based upon their relative populations. So we got a few definitions from Friday. We had seats. Seats are going to be those items that we are going to be splitting up. We have a house size. House size is the total number of seats that will be assigned. So this is the representatives, the money, what's going to be given out amongst these states. The states are going to be the individuals receiving the seats. So in terms of the United States House of Representatives, the states are, well, the states. In our example on Friday, our states were the freshman class, sophomore class, junior class, senior class. Within there, we have the state population is the size. A measure of however we're going to talk about the size of the state, be it money, be it buildings, be it the population. And then we've got total population, which is every state population added up. So what we need to get out of today are two, what we're going to call quota methods of apportionment. And the idea behind quota methods of apportionment is exactly the way we started things off on Friday when we were talking about splitting up the representatives for the Glastonbury High School Student Council. Now, Hamilton's method is going to be the natural case. And it was first proposed as the method of apportionment for the representatives by Alexander Hamilton, the guy that's on the $10 bill. So very first Secretary of the Treasury. Now in the Constitution, it lays out that the House of Representatives is going to be apportioned based upon state's population. It was originally stated that each state receives one representative for every 77,000 people. Didn't work out so well. Big thing in the Constitution is that it's going to be done proportionally. By the House of Representatives is going to be done proportionally. Didn't stipulate how. So it was opened up to different possibilities. Now we know 1789, the very first president, George Washington comes into play. Says, okay, we got to figure this stuff out. We got a brand new country. Let's hear some ideas. So Hamilton throws up his method, gets it proposed. Washington looks through it. Oh, this is great. Nice and easy. Unfortunately, Washington lived in Virginia. Virginia's a southern state. Agrarian economy compared to Alexander Hamilton. Lived in New York, northern industrial economy. Washington's a little bit uneasy. What eventually happens is that his buddy TJ, Tommy J, President number 3, very first Secretary of the State, Thomas Jefferson, the guy on a $2 bill, proposes a different method. Now that's not one of these. Jefferson's method is going to be called a divisor method, in that we're going to adjust the divisor compared to the quota. I'll get to that in a moment. Hamilton's method, it worked out nice. It's very easy to do. Very first presidential veto. Washington said, nope, we're going with Buddy TJ's idea. Jefferson and Washington lived in Virginia, two southern states. The way the methods worked out is that one method actually favors different size populations, and it ended up, Hamilton's method favored the North, Thomas Jefferson's method favored the South. Dawnings that would later lead to something called, you may have heard of it, the Civil War. It's already starts of kind of a disconnect between the North and South. And we'll even see that with the second method that was proposed, Lowndes Method. So let's just take an example and see how it works. Doing something that, well, makes sense. Let's say we've got states A, B, C, D. So those are going to be our 4 states. Putting some numbers here. Let's say that our house size, the total number of seats that we are going to apportion, is 40. Populations that we're going to have, 323, 408, 362, and 430. Because why not? We need to take this 40 and split it up evenly. What we're going to do is we're going to first start off, find our total population. And our total population is going to be the state populations added together. So take that out. We got to add things up. Can you see that? Nope, not too well. 323 plus 408 plus 362 plus 430. We got a total population of 1523. From here, we're going to find our natural divisor, and this was a definition that we had on Friday. Our natural divisor is the straight up, it's the ratio of population to representatives. So we call this our natural divisor. Our natural divisor comes from the total population divided by the house size. So we have 1523 divided by 40. We get our natural divisor, 1523 divided by 40. It's going to be 38.075. Now that's population, people per representative, or people population per seat. Natural divisor. Now, taking this, what we did on Friday with the populations of the classes in Glastonbury High School was we took the state populations. We have 323 people. We get one representative for every 38.075. We just divide. So I'm going to take the state population divided by the natural divisor. This is going to give us what we call our natural quota. This is the raw, straightforward ratio of how many seats we should have. So state population divided by natural divisor, we've got 323 divided by 38.075. For state A, we should have 8.483 representatives. State B, we have 408 divided by 38.075. We have 10.716. State C, 362 divided by 38.075. We have 9.508. We have 430 divided by 38.075. We have 11.293. These numbers are what we call our natural quota. Natural quota was the state population divided by the natural divisor. Now, initially what we're going to do is we're going to take all of these natural quotas, we're going to round them down. So 8.483, state A receives 8 representatives. State B, 10.716 gets 10. 9.508, we get 9. 11.293, we get 11. We get a total representative size that's 18, 27, 38. But we needed 40. Now the way Hamilton's method, kind of obvious in this list right here. The way Hamilton's method works is we first find the natural quotas, immediately round everything down, determine how many seats we currently have assigned, and since we need 2 more seats, we have 38, we need 40, what we're going to do is we look at the 2 highest decimals. So this 0.716 is the highest decimal. 0.508 is the second highest decimal. So states B and C are going to get the additional seat. That's going to put B up to 11. C is going to get to 10. D stays at 11. A stays at 8. We have a total of 40. And this set is going to be called our Hamilton quota because we use the Hamilton method. Oops, I keep spelling quota wrong. The Hamilton method to find the apportionment. And that's how we would apportion that set of seats. Not so bad. Now this worked out nicely because there were 2 seats, 2 states that would have rounded up. But regardless, Hamilton's method, however many seats that we still need to reach our correct house size, we had 38, we needed 40, we look for that many, the highest decimals. Go for those that make sense. Hamilton's method, nice and easy. Great, except that favors just the largest size. Along comes South Carolina Congressperson Samuel Lowndes, 1832, proposes a different method, South Carolina, 1830s. What's happening? Not a lot. South is getting kind of angry that the larger states in the North keep getting more and more seats. Smaller states in the South don't have the same representation in the Congress. So South is getting a little bit annoyed here. 1830s. What's happening? South is getting pissed off. So Samuel Lowndes, 1832, proposes another method. Let's see if we can take these numbers, change them up a little bit. I'm just going to take these, copy them down. We're going to say our house size is, again, 40. We've got our 4 states, A, B, C, D, 323, 408, 362, 430. Same as that. We have total population, everything stayed the same. Total population, 1523. That means our natural divisor, 1523 divided by 40, we have 38.075. Natural divisor, we took that and found all of our natural quotas. Natural quotas, we had 8.483, 10.716, we had 9.508, 11.293. Now the Lowndes method, we are going to go by the Lowndes method of apportionment here. A little bit different. Hamilton looks at the largest decimals. Lowndes uses what's called the largest relative fractional part. What we do is we take the decimal portion of our natural quota divided by the integer portion, the whole number portion of our natural quota. So we take the decimal divided by the integer, the whole number, and we just called our relative fractional part. Relative because we are comparing the decimal to the integer. So for example, state A, we have 0.483 divided by 8. See that? You can see that. Scroll up. We've got 0.483 divided by 8. We have a relative fractional part of 0.0603. State B, we have 10, nope, I lied, 0.716 divided by 10. That gets us 0.0716. State C, we have 0.508 divided by 9. Oops, wrote on my calculator. We have 0.0564. State D, we have 0.293 divided by 11. We have 0.0266. Now, before we took all of our natural quotas, we immediately rounded them down. So 8, 10, 9, 11, we have 38. The whole idea behind quota methods of apportionment is how do we take this 38? We need 32. How do we assign, to whom do we assign the additional 2 seats? Hamilton's method, we just go for the largest decimals. Nice and easy. Largest decimals, you're the closest to being rounded up. Even if you're not above 0.5 in the natural way, take the largest decimals, you get the seats. It favors the larger states. So we've got 10.7. Well, they've already got 10. Now they're up to 11. 9.5. They've already got 9. They're up to 10. If you're state A, you're a little bit unhappy. You're already at a disadvantage by only having 8. What's happening now, the Lowndes method, is that instead of just looking at the total decimal, we look at this largest relative fractional part. We need 2 more seats. We calculate out the relative fractional parts. We choose the highest two because in this case we had 38, we need 40, we need 2 more seats. We go through. State B gets a seat. 0.07 is the greatest relative fractional seat. State A gets an additional seat. 0.06 is the second highest decimal out of our list. So the Lowndes method assigns the additional seats necessary based upon the largest relative fractional point. So in this part, A and B, get the additional seats. So now we're up to 9, 11, 9, and 11. Look at that. There's our 40. The nice part about the Lowndes method is that it favors those smaller states, those that are already at a disadvantage. And there's one very clear, really nice outcome if you're a small state, and you'll see that in a practice for tonight. Take a look at Iceland. What happens to Iceland when you use the Lowndes method? I'll put these up. I've got a few other notes that I'll put up on the Google Classroom as well. You've probably already seen that, as well as and we'll figure out some things from there. Should be in tomorrow. Have a good day. Thanks.